All right, so this is AP Calculus 3.4 concavity and second derivative test. So everything that we've been building up in Unit 2 is coming up to this stuff. Because all you're doing is the exact same we did, just doing different things with it. So the hard part, the calculus part, was actually doing the derivative. Everything else is algebra out of this cell. It's algebra and some trig. Okay, to try and figure out what it is we're looking for. So, definition concavity. Let f be differentiable on an open interval I. The graph of f is concave upward when f prime is increasing on the interval, and concave down on I when f prime is decreasing on the interval. So, if you notice this right here, all this right here is increasing, right? From here up, this is increasing. So this is my concave upward, where this right here is going to be my concave downward. Just think of it like a little cave. Concave. Anyway. I tried, sorry. Anyway. Definition concavity. Define the open intervals in which the graph of function is concave upward or concave downward. You need to find the intervals on which that f prime is increasing or decreasing. So, let's figure out where this is increasing and decreasing.
Derive. We have to derive.
Take the derivative. So if I take the derivative of this, so f prime of x is equal to
X squared minus 1.
X squared minus 1. So, factor it out.
X plus 1, X minus 1.
So, x plus 1. X, that looks like a lambda, sorry. Equals.
I'm looking at 10 too.
Right?
Yes.
Okay, so we have the derivative, and why did I want to factor that?
Because we can find our critical points.
Yes, I can find those critical points, so set it equals 0. Okay, so set it equals 0. So it's going to set it equals 0 for x plus 1, x minus 1. So x equals plus or minus 1. So if I were to have so I have negative 1, positive 1. So right here. So we pick a number. So on the intervals to actually try and test this here. So let's see. So on the other side of negative 1, to the left side of negative 1, you're going to pick?
Negative 548.
Okay, negative 548.
The cube, the root of
So
3.
negative 548 in here is going to give me a negative, right?
Yeah.
Okay, negative 548 is also going to give me a negative here, right? So a negative and a negative makes a? So that means that this one right here is positive. See what I did there? Now, in between negative 1 and 1, 0. 0. Plug in 0 to here. So if I plug in 0 right here, it's going to be a positive 1. Plug in 0 here, I get a?
Negative 1.
So together when I multiply that, I get a negative. Now the other side of 1.
Positive 548.
Positive 548.
Like that.
So this, my left one here, this one here is going to be positive, and this one here is positive. Positive makes a positive, positive. So let's take a look. Now, please, let's take a look here. So given this information, I know that at negative 1, I have a what?
You have a change? You have a 0?
You have a max, right? Okay, so it should be a max because it's increasing
Then decreasing.
and then decreasing afterwards. So that's going to be a max. And then over here, to a positive 1, it's going to be a minimum. So if I were to try and do a basic sketch, it would look something like this.
A roller coaster.
Yep, something like that.
Is that a sign?
Yeah, basically. But it's not going to be a sign, it's an x cube, so for whatever reason. So I know that I have a maximum here and a minimum here. So somewhere in between here, it changes concavity. Somewhere in between there, it changes concavity. So at -1, It is
Concave downward.
concave downward. At positive 1, it is
Concave upward.
very good. Yep. Makes sense?
Yep.
So if I take the first derivative and I sketch it, it makes sense of what I'm doing, right? Okay, so I graphed each one, I plugged in points, and I can do that. Now there's going to be other ways of doing this. There we go. Okay, definition of concavity. Test for concavity. Let f be a function whose second derivative exists on an open interval. Has to exist. I have to be able to take the derivative there, right?
Did you have to be able to take the second?
Second derivative also. So that means that I need to first derivative and second derivative, and it has to be continuous through that, right?
Yeah.
Okay, that's what I'm looking for. All right, so says f double prime of x is greater than 0. So that's the second derivative is greater than 0 for all x in I, then the graph is concave upward. That's important, concave upward. So positive concave upward right here. For this, if it's less than 0, so that's negative, so that's going to be concave downward. Now, but think about this. You have to like seriously picture this piece right now. If you're picturing this in your head, a concave upward is going to be a what type? Min or max?
Min. Because it's like this.
Yeah, my bad, man.
If it's concave upward, it's like this, right? So it's concave upward, so that means it's a min. And then right here, if it's concave downward, it's going to be a max. So this would be a max right here, like this.
Wait, so it's like the concavity, is that just kind of the turning point?
Cavity. Is that when you eat too much sugar?
I'm about to get a cavity after that lollipop.
Okay, I'm sorry, what?
Is the concavity, is that just like the turning point of the slope?
It's kind of. So you're going to actually have to find the points in between. Do you guys recall what those points are called?
Points of inflection.
Points of inflection. There we go.
Inflection?
Yes, inflection. That's what I was talking about on the previous one. And I said somewhere right in here, it changes concavity. That's called your points of inflection. So that's what we're looking for.
Is there a way to calculate that?
Yes,
Oh,
there
that's
is.
a second derivative, isn't it? When it's 0?
Okay, so let's read.
Oh.
To apply theorem 30.7, locate the x values at which that the
Makes sense.
second derivative is equal to 0.
The acceleration.
Second derivative is equal to 0.
Or F
Okay.
prime X?
F double prime does not exist, okay, or it does not exist. Use these x values to determine the test intervals. So that's going to test my concavity. So now, if I'm going back and looking at this again, this is concave down here, right?
Yeah.
That's concave down. So now, all this is down, 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 except at some point, it's going to change, and all of a sudden, it's going to become up, 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 right?
Offset.
That's what I'm using my second derivative for. So this, where it changes, is my second derivative equal to 0.
Oh.
Okay? Second derivative equal to 0.
Now it makes sense. Oh my god.
So we use that to do my test intervals.
I'll come around the unit circle.
Okay, to determine open intervals on
Too tight.
which the graph of this is concave upward or concave downward. So let's take the derivative. So if it's going to be f of x equals e to the negative x squared over 2.
Holy crap. It's
No. What's the derivative at the top?
it's
Negative 2x.
it's negative x.
Negative, wait, no, negative 2x.
No, because look, this is fractional, right?
It goes up. It
So
goes
this
down.
right here, 2 goes up front,
Negative x.
right?
Yes.
And then 2 is going to cancel.
My fault. My apologies.
So it's just going to become a negative x, right?
That wasn't clear.
Negative x e to the negative x squared over 2.
This is gonna be amazing. X squared.
Okay, so now, this is where algebra comes into play. Now we need to
Produce.
f that.
Oh.
Oh, you're
What are we
right.
gonna have?
I could f that, right? Or I could use product rule to go to my second.
Yeah.
So I could use first derivative to find my points normally. That's using the first derivative test. But,
How do you add that?
huh?
Are you at that?
Well, we would factor it, right?
Yes.
So wouldn't it just be x equals 0? And then set that equal to 0? And then e to the negative x squared over 2 equals 0?
X equals negative.
That would be your critical points for your first derivative, right?
Negative x equals 0.
Yeah, so that's what I would do. I would take that and set it equal to 0. Right? Okay. That's your first derivative
I
test.
would jump into the second derivative.
Okay, so now let's jump to the second derivative. So second derivative, it's going to be product rule, right?
Yeah.
So product rule, so it's going to be f double prime of x is equal to negative e to the negative x squared over 2 plus, no, it's going to be a minus, right?
Negative e to the
Oh, yeah.
It's minus,
Negative.
actually, hold on, I want to take the derivative.
It's gonna be positive.
It is going to be a positive, right? So it's going to be a positive,
It's like
okay? So the derivative of the x is just 1, so I got that. And then when I take this one again, so it's going to be
X squared.
x, right?
Squared.
Nope, because I already took care of that. What, the derivative of this. The derivative of this is negative 1, which I took that. But then, here, let me back up, because I think I'm confusing you guys here with all this. No, I'm okay. So, derivative of this.
not fine.
Derivative of this.
Then negative 1.
Very good. So it's plus negative 1, right? Okay. So we have,
Wait, look.
crap. Let me back it up. One more time. Sorry.
Back the truck.
I know. Sorry. All right. So I'm going to write it out.
No, because it wouldn't be negative 1 times the e.
Negative
You have
x
negative 1?
times the derivative of this, which is the same as my first derivative.
So negative.
So I'm going to have negative x e to the negative x squared over 2. There we go. Sorry.
So it's x squared.
Yeah, it's going to be.
Plus x squared.
Okay, so now two negatives. We'll make that one a positive, right? So f double prime of x is equal to negative e to the negative x squared over 2 plus x squared, right?
To the negative x squared.
E to the negative x squared over 2. Now, can I do any factoring?
You can take out e to the negative.
Take out a negative e.
Oh.
Take out a negative e. So f double prime of x is equal to a negative e negative x squared over 2 parentheses. Isn't that going to be x squared minus 1?
Wouldn't be 1 minus x squared?
It, okay, am I factoring on a negative?
You know this.
You did.
Okay, so I have, oh, you're right, you right.
You're right.
You right? Dang, I am off my game today.
It's Friday.
I know, it's Friday. No, never mind, I won't go there. So I have 1 right here. So I have 1, and that's going to become minus x squared.
Yes.
Right? Okay, so since I have that, what can I do with this piece over here in parentheses?
Solve at 0.
Factor it.
Oh,
Factor
yeah.
it. I got different squares, don't I?
Yeah.
So now I go 0 equals
Negative.
negative e to the negative x squared over 2. And it's going to be 1 minus x and
1 plus.
1 plus x.
Oh, that makes sense. Or doesn't?
Does it make sense?
Yes, it does. Makes sense.
It's been so long since you did math.
4 hours.
Normal math.
Okay, so I'm going to carry this over to another page so I don't lose it right here. So
Can you
0 equals
negative e. Negative x squared over 2.
okay, so I carried it over to a new slide. So now set each one equal to 0. So it's going to be 0 equals negative e to the negative x squared over 2. And I have 0 equals 1 plus x, 0 equals 1 minus x. Alright, so let's do the easy ones. Over here.
So x equals plus or minus 1.
So x equals negative 1, right? Okay, this x equals positive 1. Okay, so if I'm doing this, divide both sides by negative 1. Still 0, right? Okay, so now how would I undo that?
Natural log.
I would ln, right? So it would be ln of 0 is equal to ln of e to the negative x squared over 2. What is ln of 0?
0.
0. Undefined. Undefined.
Y'all got calculators.
Here, I got you guys. Where's the line though? Found it. It's undef.
I have
Undef right there.
It's undefinitionable.
Okay, so is this one going to work?
No.
No.
That part's not, so what am I going to do with that piece?
I'll use.
I can't use that, right? So I'm going to disregard that. Because
It looks bad on the graph.
because of that, it's undefined there, right? Yes. Okay, so I can't do it there. Alright, so that means that I'm going to have inflection points here and here. I'm going to have inflection points there and there. So if I were to graph my thing, so points of inflection is going to be negative 1 and 1. So I'm going to have some inflection points. So that means those are the places in which that's going to change concavity, right? Okay, so let's go ahead and with those pieces, I have it set equals 0. So now let's find numbers in between.
0.
548.
No, let's use real numbers because this one sucks.
Negative 2.
So let's go 0 for in between, negative 2 here,
Negative 10.
Positive 2.
Okay.
positive 2.
Negative 10.
Okay, so let's see what we got here. So this part I have, for this piece right here, just this,
You can go back to that.
this is going to give me for negative 2, that's a negative 1, right?
Yes.
Negative 1. So I have negative 1 for this right here,
And a negative 2.
and a negative 2. Negative negative is positive. Now it depends on what happens over here. So for this piece right here, so plug in a negative 2, negative 2 squared.
I got you guys. I got bars.
Negative 2.
You just put negative 2?
Negative
It's
e to the
negative.
So it's negative 4 divided by 2 is negative 2.
Negative.
E to the negative 2.
1, 3, 5.
negative e to the negative 2.
So it's going to look like this, negative 1 over e squared right there. So is that going to be a positive or a negative? That one's a negative, right? Okay, so that one's going to be a negative there. So I have a negative. This one is a
Negative.
negative, and this was a
Negative.
positive.
Was it? Oh.
But enter. You didn't.
So negative,
What the heck?
negative, and positive.
It'll be positive.
So all this right here is going to be a positive, right?
Yes.
Plus.
Plus.
Let's do zeros.
I think not. 0, 0, 0, 0.
All right. For this piece right here, plug in 0.
1.
I get a positive. Plug in 0.
Positive.
Positive. And
You plug in 0, you get a negative.
clean this up right here. This is going to be 0, right? It's 0, right? So e to the 0 is,
Negative 1. It's 1, but
it's going to be negative 1, right? So that's negative 1. So this is a negative here, right?
So it's negative.
So I get a negative value here. All right, so let's go through it again. All right, so for 2, for this right here, 2 is going to give me,
Positive.
Positive.
2's right here,
Negative.
and right here, this one's going to be 2, so it's going to be the same thing as this one right here,
Negative.
right? Okay, so this is going to become a negative. So that means that my whole thing over there is going to be a
Positive.
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 Yeah.
We have a max and a min.
No, we have
If it has
2
to
points
change,
of it.
you can just,
We have a max and a
it's
min.
positive, negative.
It doesn't have to.
The second-
Remember when we're doing our first derivative test?
Oh, yeah.
We actually have some that actually don't change. We go positive, positive.
Oh, yeah.
Yeah, when we have graphs and it will look like this, it'll go positive to a point,
And then go back up.
and then again positive, like this. Okay? It's possible to have something like that, you know, but still, you can't just assume.
Franny gets mad if you do.
Huh?
Franny gets mad if you assume.
Alright, so now, given that information right there, what do we know?
We have 2 points of inflection.
We know that over here, this is
Positive.
positive. So if it's positive, it is
Hey, down.
Concave.
Concave. Upward or downward?
It's downward.
my board is slowing down on me.
Downward concave.
Downward.
Downward concave.
Oh, there it is. It's
Downward
the wrong
concave.
side. So if it's positive,
Wait. It's upward.
positive, it's concave up.
What?
6 days.
Huh?
Because f double prime is greater than 0, so it's positive.
Oh yeah. Ooh, my bad, my bad, my bad.
That makes
But I
a
think
whole
about
lot
it
of
like
sense.
that,
Uh
though.
oh.
So it's
Spaghetti.
Yeah, don't think about it like that. It's opposite to this. Okay, the second derivative is greater than 0.
Yes.
Second derivative is greater than 0, so that means positive numbers. It's going to be concave upward. So think of greater than 0 up.
Less than 0.
Is that a way to do it?
What do you mean?
Greater than 0 up. Less than 0 down.
it's the opposite of what we're writing.
Oh.
Okay? So greater than 0 is up.
Yeah.
This method.
Greater than 0 is up. So this is concave up. So if I'm looking at this, so over here it's going to be like up. And right here it's going to change. Concave down. And then right here it's going to change like this.
Can you put like vertical lines so you can see the inflection?
That's beautiful.
There you go.
Right there.
Those are vertical.
Something like that.
Vertical to me.
Oh, because somewhere in here, so from my graph, it's going to change concavity. So if I were to do my first derivative, I would have a 0 slope somewhere in here, somewhere over here, or maybe even somewhere over here. So I know I have a definite one right in here. I have a definite one in the middle. Okay, because at the end it could be just concave, you know, with the gradual. Okay, same thing the other end. Could be a concave up gradual. So it's going to be a constant, just always like that, like going to an asymptote. Does that make sense? Hopefully.
Yeah.
All right. So now let's take a look at. Okay, so determine concavity, open intervals, which we get that graph, concave up, concave down. So what do we have here?
Quotient.
Yep. Okay, so let's do quotient. So f prime.
What do you call it? No. Like, we gotta put
2x quantity, x squared minus 4 minus
You got a question?
2x quantity, x squared plus 1, all over x squared minus 4 squared. Yes? Okay, so do my distributing. So that's going to be 2x cubed minus 8x minus 2x cubed minus 2x x squared minus 4 squared. So my this
They cancel those.
and this, so you're left with negative 10x over x squared minus 4 squared.
Let me guys do this. Question again?
Right?
Song.
So we have that, and so now, since we're trying to get to my second derivative,
Quotient.
got to do quotient again, right? So f double prime of x is going to be negative 10 quantity x squared minus 4 squared minus negative 10 x times 2 quantity x squared minus 4 times the derivative of the inside, which would be 2x. All this is going to be over x squared minus 4 to the 4th, because I raised the square squared. Did I lose anyone right there?
No. You almost. You were about to, but then you stopped.
Looks like you're zoned out.
Now I can clean up.
Alright?
Clean up.
So, now, let's go through. We got a whole bunch of stuff to clean up here. Let's see if I can clean it up right here.
Don't we have to boil that though?
Let's...
That's
That's not.
No. Can I factor first?
Yeah.
Yeah.
You
Okay.
take out an x squared minus 4.
Yeah, I'm going to take it on x squared minus 4.
You ain't gotta boil anymore, boys.
And so I'm going to be left with a negative 10 x squared minus 4, right? So I took out one of those.
Minus 10.
So it's going to become plus.
Minus.
That's going to be 10. And I have these over here.
What you mean 10 out?
That's 40, right? That's going to be 40, right? X
Squared.
squared. Is that it? Yeah. Is there anything left over there?
The bottom.
I know, but over here. Because I took out this piece right here because it's all multiplying together. And
No.
so I have the here, all that together.
You could factor 10 out. Put on top.
Nah, I could. Okay. I don't know if that will help me, but it might.
It'll look cool.
It will look cool.
It'll look cool.
So I have my x squared minus 4 to the 4th. Okay, cancel out one of those. So that cleaned up a whole lot of math. Over there, let's go ahead. What do we get after this distribution?
Wait, wouldn't it be wouldn't now the bottom be
3. It is 3 because I canceled out one of them, right?
yeah?
Is that what you're trying to get at?
No, my head's trying to figure something else out.
Okay. All right, I have negative 10 x squared plus 4x. No x.
Oh, it's 40.
How do you do that? What do you do that?
Uh,
40, 30, maybe.
so plus 40. And then I'm going to have plus 40x squared. All that's going to be over my x squared. So I can combine like terms right there.
Wait, so wouldn't the bottom be the x squared minus 4 squared times the x squared plus 4?
It stays this, right?
Oh wait,
Yeah.
yeah.
Now, I'm going to set this equal to 0, right? Now, there's a reason. I'm not worried about the bottom because when I set it equals 0, what's going to happen?
You're gonna F that out.
The entire bottom goes away. Alright, so was it 10 x squared? I'm going to take it to another slide.
How does the bottom
Squared
go away?
minus 40.
Hold on.
0 times
So what was it?
What equals what?
So f double prime of x was what? It was negative?
Negative 10x squared plus 40 plus 40.
Your brain working out.
I'm back on track. The cogwheels are spinning again, boys.
Minus 4?
Wait, can we combine that?
I'm going to. I needed a new slide. Right here. Minus 4. So did I copy it right?
Yeah.
Because I don't want to actually do the math if I miscopy. Okay, so clean up the top.
30 x squared plus 40. 30x squared minus 40.
Plus 40.
Plus 40.
Plus 40, guys.
Over.
X squared minus.
Okay, so now that I have it all there, now I'm going to make the math really easy.
Multiply that by 0.
Nope.
Multiply by
Set it equal to
Oh,
0.
my bad.
set the second derivative equals 0. So 0
Two ahead.
equals
Sorry, Jane.
30x squared plus 40 over x squared minus 4 to the third. All the bottom goes away, right?
Yeah, he just disappears into the black hole.
Okay, so now I'm going to have 0 equals 30x squared plus 40. So what am I going to do? Subtract 40, divide by 30,
Negative 4 thirds
negative 4 thirds
equal to x squared.
is equal to
2 rad 3 over 3.
Can we take the square root?
Negative 2 rad.
I can't, can I?
Yeah.
2x to the fourth.
Nope.
No, because it's imaginary though.
Yep, can't.
Wait, I'm retarded.
So,
Error.
I hope not. All this right here, if I get to this point, what would this tell me if it's imaginary?
It played us like a
Is that
fool.
applicable?
Nope, try it. Think about it.
Wait, no, it said something about it back here. It says or s. Never mind.
So what does that tell me? If I do not have any places in which it's equal to 0,
Then there's no point. of
Does not
inflection.
exist.
there would be no
Points of inflection.
points of inflection, so that means it's all over the entire interval.
It's all either concave upwards or concave down.
Very good. It's either all concave up or concave down.
That's just a friend.
So we use the 2
Okay.
before.
So I'm not going to have it there. So now because of that, okay, it's either concave up or concave down.
How do we
So
do that?
either way, so now let's go ahead and test it. So if I was to test this, it would be what? So find a number. What number would be the easiest?
Zero.
Zero.
Okay, let's plug in 0. Now, what do I have to be careful about?
Making the denominator
The-
zero.
the-
Thank you, make the denominator equal 0. So I just got to make sure I don't do that.
But it can't be equal to.
You right.
You're right.
Okay, so now let's say f double prime of 0 is going to be, on the bottom, I'm going to come up with negative 4 to the third, which is,
Negative 64.
okay, and then 0, 0, so it's just going to give me a positive 40, right?
So that's
Oh, it's a neg. So it's all concave down.
So it would be negative, okay, negative,
So it's all concave down.
all concave down.
I'm definitely gonna have to watch this video, but I just stopped already.
Hopefully you don't double check the video and find out I made a mistake in the math and, totally screwed up the whole thing.
Maybe we actually can't find the points of inflection.
I know, right? Okay. So,
I'm pretty sure Dave will find that out real quick, huh?
Derek, you mean?
Not like Derek.
Derek,
Derek will find it.
Young Yeezy. All right.
Oh yeah.
Oh yeah.
Young Kanye.
Okay, so you got some practice problems here.
Wait, Patrick, I have a complaint.
Yes.
You finessed me with 2 points.
Hold on.
You finessed yourself.
Nah, he finessed.